Discrete Probability Distributions. The outcome of a fair dice is represented by the discrete random variable x, and x here, because it's a random variable, it's uppercase, and we can shorten this to DRV, discrete random variable. It's discrete because the outcome can only be one of the numbers on the faces of the dice. It's random because we don't know what the outcome will be until we carry out the experiment, and if we do multiple trials the outcome will vary, so it's a variable. And we can take the outcomes of x and represent them in a probability table. The sample space of x goes along here, and it's a fair dice, so all of these probabilities will be 1/6 each. So what we're looking at here is a table that represents every single outcome possible for this dice, and that's the sample space of x along here, the numbers 1 to 6, and their respective probabilities. We call this a probability distribution table, and a probability distribution shows the probability of every possible outcome in the sample space. So the random variable is always represented by an uppercase letter, and the value that it takes is represented by a lowercase letter. So these are the values that the random variable can take, so we are using lowercase x here, and all this is saying is probability. Because all values in the sample space are listed here with their probabilities, the probabilities will add up to 1. We can represent this graphically. So x is a discrete random variable, and these are the values that it can take, and because the dice is fair we can see a uniform distribution. So we have probability against the outcomes of x. When calculating probability you'll see something like this. So the probability that our discrete random variable takes this particular value. So for example, the probability that x is equal to 2, 1/6. The probability that the discrete random variable takes a value that's less than or equal to 2, so the random variable could be equal to 1 or 2, so we have to add these probabilities together, and then we can simplify. Example 2, we have a 5-sided spinning top. When this stops spinning it will land on one of these 5 sides. These numbers make up the sample space. The spinning top is biased, it's not fair. If it was fair, the probability of each of these would be 1 chance in 5, because there are 5 sides. So first of all there's a value missing here, and we can see 6 is absent from the table, and then we know the probabilities all add up to 1 because we have every value in the sample space listed here, so their probabilities add up to 1. So the missing value is 23 over 120. So this is the probability distribution of the discrete random variable x. Now we can calculate probability. So the probability that x is even, so it could be 2, 4, 6 or 8, but not the 1. We could add up these probabilities, or we could do 1 minus 1/3, which gives us 2/3, which is quicker. The probability that x is a value greater than 3, so values greater than 3 include the 4, the 6 and the 8, so we have to add these probabilities together. So 1/4 plus 1/8 plus 1/10, which gives us 19 over 40, or 0.475. The probability that x is equal to 9, there is no outcome here, that's 9, so 0.